Hey guys, this is Chapter 5, Section 3, which is Solving Systems of Equations by Elimination. And this is going to be the last way we're going to look at solving systems of equations. So far we've done graphing and we've done substitution. But there's going to be times where graphing doesn't make much sense and substitution can happen. So far, when we've done questions for substitution, we looked at an equation like this, or a system like this, where one of the variables, in this case the y, right here, has a 1 in front of it, or there's no number there. So we could rearrange the equation, we could get y equals something, substitute it in, and then solve. But what happens if none of the variables are alone and they all have numbers in front of them, like if there was a 6 here? Then you have to use something called elimination, and it's not hard. You just have to take it step by step. So I'm going to do a couple examples and then a word problem, and then that'll be it. So in this example, to use elimination, you are going to be either adding or subtracting the systems from one another. So I'm just going to make a note of that up here. You're adding or subtracting the systems, or the system. And the goal is to eliminate one of the variables. So in this case, I have negative 6y and positive 6y. So if I added negative 6y plus 6y, that would be 0, which would eliminate this from the equation. So what I would be left with is 5x plus 3x, those are like terms. So I would have 8x plus 0 equals, and then negative 32 plus 48 is 16. So now if I rewrite this, 8x equals 16, because 8x plus 0 is 8x, and then divide by 8, that cancels out here. I've got x equals 2. Now, what I've just done is I've eliminated the y's by adding them together. I solved for x. I have x equals 2. And now all I need to do is plug this 2 back into one of the original equations and solve for y. And then I'll have my total solution to this system. So I'm going to use the first equation. It doesn't really matter. 5x minus 6y equals negative 32. I'm going to plug in 2 for x, because we just solved and got x equals 2. Okay, need to scroll down. 10 minus 6y equals negative 32. I'm going to add, I can subtract 10. Subtract 10. Now I've got negative 6y equals negative 42. And if I divide both sides by negative 6, divide by negative 6, I'm going to have y equals 7. Sorry. And then that means the solution to this system is x equals 2, y equals 7. Okay? And just to recap what we did real quick. To do elimination, you're going to add or subtract the systems together. I'm going to show you a couple examples of adding and subtracting so you can see when to use each. But the goal is to eliminate one of the variables. In this case, I have a negative 6 and a positive 6. So if I add those two things together, that will eliminate. So then I add all of the other pieces together. So 5x plus 3x is 8x, and that's 16. And then I'm solving for one of the variables. And then to get the other answer, I plug in my variable to one of the original equations and solve for the other thing. So let's look at another example. Let's do 3x plus 4y equals 16, and then negative 3x plus 2y equals 8. It's going to be pretty clear to me that I'm going to use elimination because none of the variables are isolated. They don't have anything by themselves. So 3x and negative 3x, if I add those two things together, that's how they'll cancel out. So I'm going to add for this problem. 3x plus negative 3x is 0. 4y plus 2y is 6y, and 16 plus 8 is 24, so 6y equals 24. Divide by 6, divide by 6, y equals 4. Now that I know what y is, I can plug it into one of the original equations, which I will do right here. Let's use 3x plus 4y. Again, it doesn't matter which equation you use. You'll get the same answer as long as you use the right math. So I know that y equals 4, so I'm plugging that in for y. 3x plus 16 equals 16. Subtract 16, subtract 16, eliminate. 3x equals 0, and then doesn't matter if I divide both sides by 3, I'm still going to be left with x equals 0. So the solution to this system is going to be 0, 4. X equals 0, y equals 4. And that's it. This is how you do elimination. Now, there's got to be someone there sitting and thinking, what happens if you've got an equation where the numbers aren't so friendly? Like, what if you don't have a 3x and a negative 3x and they can just work like that? What if you've got something like this? 10x minus 7y equals 2 and negative 5x plus 3y equals negative 3. Nothing's going to eliminate right off the bat. If you have something like this, there's one added step. So I'm going to, in case you're taking notes, this is something I would write down. Sometimes you also have to multiply, and I will show you what I mean right now. Nothing is going to cancel out easily, but if you know your factors well, 10x and negative 5x, if I could somehow change this negative 5x into a 10x, then these would cancel out. And the way to do that is by multiplying the whole entire equation by, in this case, it's going to be by 2. Because 2 times negative 5 is now negative 10x. 2 times 3y is 6y. And then 2 times negative 3 is negative 6. So all I've done is I've multiplied all of the pieces of this part of the equation by 2, because that will change negative 5 to negative 10, and now I can eliminate 10 and negative 10. So I am going to just cross this out just so I know that I'm not using it anymore. 10x plus negative 10x is 0. Negative 7y plus 6y is negative 1y. And 2 plus negative 6 is negative 4. So now I've got negative 1y equals negative 4. And I'm going to divide by negative 1, divide by negative 1. And that's going to leave me with y equals 4. So I've found half of the solution. To find the other part, I'm going to substitute 4 back in for y in either of the equations. I'm just using the first one. Doesn't really matter. So 10x minus 28 equals 2. Add 28, add 28. Okay, and then divide by 10, divide by 10. X equals 3. And then the solution to this system is 3, 4. But I'll really quickly recap what happened. If there aren't two numbers that are going to eliminate easily right off the bat, in this case we had negative 5 and 10, you can change a whole equation by multiplying, okay? So always remember, you can multiply to change an equation, but you have to multiply all of the parts of the equation. So in this case, 2 times negative 5, 2 times 3, and 2 times negative 3. And that got me a new equation, and then I could eliminate. This time I added. All right? I'm going to do one more example. If you want to pause and try it yourself without me, then you can skip and see if you got the answer right. Otherwise, you can just watch. The equation or the system that I'm going to use is 8x minus 3y equals 4, and then negative 4x plus 4y equals 8. And this is another example of I don't exactly have two numbers that will cancel out, but if I multiply this negative 4 times 2, then it'll be a negative 8, and that will cancel out with this 8. So I'm going to multiply this whole entire equation by 2. So 2 times negative 4 is negative 8. 2 times 4 is 8. And 2 times 8 is 16. So now I've changed that equation to this, and I'm going to add, because 8 plus negative 8 is 0, so 0. Negative 3 plus 8 is positive 5. And 4 plus 16 is 20. So 5y equals 20, divide by 5, y equals 4. So there's half of the system, and then to solve the rest, I'm just going to use 8x. Oops, that's a minus. 3y equals 4. 8x minus 3 times 4 equals 4. And then just solve it out real quick. Okay, and if you got x equals 2, you're in good shape. So that leaves the full system solution to be 2, 4. X equals 2, y equals 4. And that is it for elimination. I'm going to do one word problem and then show you the summary questions, which I want you to try. And that's it. So here we go. At the store, Ricky bought 4 pencils and 6 erasers and spent $2.60. Sharkeisha, on the other hand, bought 4 pencils and 10 erasers and spent $3.80. Solve the system of equations to determine the cost of 1 pencil and the cost of 1 eraser. So the directions clearly state you're going to be using a system, so I need to set up 2 equations. So for Ricky, I am going to say his total was $260, and he spent that on 4 pencils and plus 6 erasers. Sharkeisha spent $3.80 on 4 pencils, but she bought 10 erasers. So this is actually going to be an example of subtraction, and the reason is 4p minus 4p is what's going to get me to 0. So this is subtraction, not addition. 6 minus 10 is negative 4. And 260 minus 380 is negative 120. Now I've got negative 120 is equal to negative 4e. I'm going to divide both sides by negative 4, divide by negative 4, and now I've got 30 cents is equal to e. So that tells me 1 eraser costs 30 cents. So I found this, but I also need to find the cost of 1 pencil. So to do that, I'm going to use one of the original equations. I'll just use Ricky's because it's on top. It doesn't matter to me. 6 times 30 cents. I'm substituting in 30 cents for E. So now 260 equals 4p plus $1.80. It's a really sloppy 2. Subtract 180, subtract 180, and now I've got 80 cents equals 4p. Divide by 4, divide by 4. A pencil is equal to 20 cents. There's the solution to that word problem. Obviously, I want you to write out your answer. So, 1 eraser costs 30 cents. 1 pencil costs 20 cents. All right, always be complete with your work, and that's that. I'm not going to do another word problem because if you can set up an equation, it's just math after that, and I think we're getting to the point where we're good at that. Of course, we'll do plenty of word problems in class, but here are your summary questions. So pause the screen, write them down, try them. Email me if you get stuck and need some help or just want to check your answers. Otherwise, I'll see you in class and we'll be finishing up the chapter. So we're almost there.